Alright, notes 5.4, the Pythagorean theorem. So the Pythagorean theorem states that for any right triangle, the sum of the squares of the lengths of the legs is equal to the square of length of the hypotenuse. Or we've seen this formula as a squared plus b squared equals c squared. So we've seen this the last couple of years. A squared plus b squared equals c squared, which is the Pythagorean theorem. Now, why this works? Well, it says draw two perfect squares from the two legs of the triangle given. Well, if we know that this leg over here, it's 1, 2, 3, 4, 5, 6 units. So a square is going to go 1, 2, 3, 4, 5, 6 units by 6 units by 6 units. So we know that this is a 6 by 6. Well, the area is, we calculate this, base times height or length times width, gives us 36 units squared. And if we look at down here, well, we have 1, 2, 3, 4, 5, 6, 7, 8 units. So we have to go 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 units. Once again, it's a square. The lengths all have to be the same. So this is 8 units by 8 units, which is 64 square units, or units squared. Now with the hypotenuse, alright, so we can measure, or well, what we also know about this is a square has to have a 90-degree angle. Well, we know that the slope of this, it goes down 6 and right 8. So our slope, negative 6 over 8. Well, if we think about that, how do we make it a 90-degree angle? Well, we figure out the reciprocal. And so our opposite reciprocal, so our opposite reciprocal, or perpendicular line, is going to be 8 over 6. So we can go up 8, 1, 2, 3, 4, 5, 6, 7, 8, and right 6. 1, 2, 3, 4, 5, 6. So up 8 and right 6. So now we have our square there. So we have our other square, we have our 90-degree angles, so we have our square. And we can sit here and calculate, count all these little squares inside, 1, 2, 3, 4, 5, 6, 7, 8, and calculate it. We can determine the length. Well, I'm just going to tell you, I already counted them all, and this is 100 square units. So if the area is 100 square units, well, then we know that this is a 10 by 10. Well, what do you notice about the two smaller areas? Well, if we add these two smaller, the A plus the B, it's going to equal the C. So the 36 plus the 64 equals 100. So that's why it's A squared plus B squared equals C squared. So the square plus the square equals the bigger square. Now, Pythagoras discovered this theorem and tried it on thousands of triangles, and it proved to be true. That's why they named it after him. So now, if we look at this, just slide this down. Any set of numbers a, b, and c that work out to be integers are known as Pythagorean, not theorem, but any of them that work out, these are triples. Because it's three numbers that work out to give you that triangle that's right. So it's any positive integers a, b, and c such that a squared plus b squared equals c squared. That will give you a triple. So if we look at a real world problem here, the following is a rule of thumb for safely positioning a ladder. The distance from the bottom of the ladder to the wall should be 1/4 of the length of the ladder. Thus, the bottom of a 16-foot ladder should be 4 feet from the wall. Well, how far up on the wall will a ladder reach? Well, we have this, well, what we know about a wall and the ground. Well, the wall and the ground forms our 90-degree angle. And then we have our ladder. So here's our ladder. It's my fabulous ladder, and we know that we said that this is 4 feet and this is 16 feet. Well, we're looking for the wall. So the hypotenuse is always opposite that right angle. So this is our hypotenuse. So hypotenuse is letter C. So we have a squared plus b squared equals c squared. Well, we have our A and our B. So we have 4 squared plus B squared equals the hypotenuse, which is 16 squared. And now we can easily calculate this. So 16 plus B squared equals 256 minus 16 minus 16. So B squared equals 240. So now we have to find out B. So B equals, what we do here is we take the square root of this. So it's the square root of 240. Now, what we can go back to is what we talked about in the beginning as our radical. Well, we can simplify this radical. So we can say that it's really, we can break down 240. I'll do that right over here. So the square root of 240, we know it's 10 and 24. This is 5 and 2. We know it's 2 and 12. There's a pair of 2's. We can break this into 4 and 3. There's another pair of 2's, so we have 2 and 2, that's 4. 4 root 15. Alright, so we know that the wall is about 4 root 15. Feet, or we could say 4 root 15 is approximately 15.5 feet, which is approximately 15.5 feet. So that's how we figure this out. That's why we started to shoot off with our radicals. Now we can look at the converse of the Pythagorean theorem. Well, the converse, if the square of the length of one side of a triangle equals the sum of the squares of the lengths of the other two sides, then it's a right triangle. So if we look at this, we can also get these inequalities. So if these are equal, we know it's a right triangle. But if that value of C is greater than the other two, then it's obtuse, which means it has a big angle, because obtuse, that side is greater, so this side is greater than those two, so it has to give you a big angle. Whereas if if A and B are greater, then you know that if A and B are greater, then it's going to give you a acute angle because the sides are closer together. So if the C by itself is the greatest, it's going to give you a big angle, whereas if A and B are greater, it's going to give you that smaller angle. And if they're equal, it gives you a right angle. So a little practice, we'll just do a couple of these odd numbers here. So if two side lines of a right triangle are given, find a missing side. We'll find a C, an A, and a B. So we'll do 8, 11, and 12. So when we look at number 8, we know that it's A squared plus B squared equals C squared. So 3 squared plus 4 squared equals C squared. 9 plus 16. So 25 equals C squared. Now don't stop there. You want to take the square root, so we know that C is equal to 5. So we just plug them all in. When we look at number 11, now we're looking for A. So we still have A squared plus B squared equals C squared. We just plug the numbers in. So A squared plus 6 squared equals 8 squared. And now 6 squared is 36. 8 squared is 64. So A squared, you subtract that, equals 64 minus 36 is 28. And now you take the square root of 28. So A equals square root of 28. Leave your answers in radical form. Well, we can break down 28 to 4 and 7, which is 2 and 2. So we have a pair of 2's with 7 left over, so A equals 2 root 7. And then when we look at question number 12 up here, so number 12, we have A is 27, So 27 squared plus b squared equals 53 squared. 27 squared is 729 plus b squared equals 53 squared, which is 2,809. Subtract this. So b squared equals 2,080. And then the next thing we have to do, take the square root of that. So b equals radical 2,080. Well, we can break this down into 10 and 208, 2 104, 2 and 50, 52. So I have a pair of 2's, 2 and 26, and 2 and 13. I have another pair of 2's. So that's one pair, that's two pairs, so that's 4. And I have 10 and 13, which is 130. So we get 4 radical 130. If we look at the next thing, find the perimeter. Well, if we want to look at this, we'll do this first one, 14, to find the perimeter. We know it's around the outside. Well, we have a 3, we have a 5, we have to find this missing side. Well, this is my A, this is C, and this is B. So a squared plus b squared equals c squared. 3 squared plus b squared equals 5 squared. So 9 equals 25. B squared equals 16. You take the square root of 16. B is equal to 4. But remember, we have to find the perimeter. We add up all these 3 plus 4 plus 5. So the perimeter is equal to, what, 12 was that? So 12 units. So that's how we can use the Pythagorean theorem to figure these out. And if we look at we can look at, well, if you look at 16, okay, what we have to do here is we actually have to find this length here from here to here, and then we have to find this one from here to here for the perimeter. Well, with this we have this is my A, this is my B, and this is my C. So 8 squared plus B squared equals 10 squared. So B squared equals 100 minus 64, which is 36. So B equals 6, so that means this is 6 units. And then for this one, once again, you have A, B, and C. So you get 8 squared plus B squared equals 17 squared. So you get, this is 289 minus 64. So you get B squared equals 225. B equals 15. So now this is 15. So the perimeter is 17 plus 10 plus 6 plus 15. So 17 plus 10 plus 6 plus 15. We don't include that 8 because that's not around the outside. We add up all these, so 17 plus 10 plus 6 plus 15, 48 units. And we just want to figure out if it's a if it's right, acute, or obtuse. We do the two smaller sides, we square them, and we see if it equals a larger side. So with this, you do 5 squared plus 9 squared should equal 12 squared. Well, 5 squared plus 9 squared is 106, and 12 squared is 144. Well, this is greater, so C is greater, which means it's obtuse. If you look at 19, the two smaller sides, so you do 13 squared plus 15 squared compared to 17 squared, so 13 squared plus 15 squared is 394. and 17 squared is 290.89. Well, this is greater, so this is acute since A and B are bigger. And if you look at 22, 3 squared plus 4 squared equals 5 squared. Well, this is 25, this is 25, that's equal, this is right. And then this is just some extra practice where you can find the area of the shaded region. Well, with this, we know that this is a triangle. We can use the triangle knowledge of our triangle to figure out what x is. So we have a right triangle, so it's a squared plus b squared equals c squared. Well, the x is c, that's x squared. We have a and b, so 3.6 squared plus 2.4 squared equals that. So 3.6 squared is 12.96 plus 2.4 squared, 5.76, and then we add them together, you get 18.72 equals x squared, and you take the square root of that. So we just know that x equals the square root of 18.72. We leave it in radical form. Now watch what happens when we find the area. Area equals x times x. Well, x is radical 18.72 times 18.72. The area is going to be, you guessed it, 18.72 units, square units. And that's just how you use the Pythagorean theorem to find different areas. So we could use it to find all of these other areas. We'll go over some more of these in class. And yes, excellent.